those gymnastics and
All right, good morning, everyone. Today we're going to go over some more acid-base calculations. Everything we're doing today is actually review in some manner. It may sound or look a little new, but we're just going over some of these items in a different fashion. So you should have a note sheet and then our final worksheet of the entire year. Acid bases too. I know, we're sad. Take a moment to process it. I know.
What a dirty shame.
Just so you guys are up to date, we are here right now. Tomorrow you have two things due. You have acid bases 1 and then your brainstorming stamps. So we are stamping the front page of your packet. So you have to come up with a hero, a sidekick, a villain, and a city, I believe, is more or less with the powers and all that. If you have questions about that, let us know. Powers are not properties of the element. I had some people write melting point and flammability. That's great, but you have to create a power out of that. Okay? We're going to end the week talking about some of the stuff. You're going to have some time integrated to work on your superhero stuff. But we're going to talk about a titration lab bet that we're going to do on Monday, which you're going to learn the equation that you've already learned. And then you can get a review if you'd like it, but it's not going to be due, so you don't have to have that if you don't want. We have a small quiz next Wednesday, and a week from now, it should probably take about a mod. So the second mod you can utilize to finish up your superhero stuff. And then Thursday is just finishing up our superhero stuff. We have single mod, and we are done for the year. Wow. So, what I'd like to do on our note sheet, try not to look at other sheets with this, is we're going to place these things. Now, normally you'd have a cue, like a spot where like this item, this pH has an item that belongs here. But we're going to try to do this totally cold. So we're going to go in order. Can anybody have a guess of where bleach might go? If you're on, it's okay.
14.
14, so at least we're staying on the basic side. That's not correct, but you're in the right vicinity.
12.
It would be 12. Winner.
That was me.
So write it on the side.
Oh wait, there's 9 to 13.
Well, it's... Okay, no, we're on the note sheet. We're not doing homework. We're on the little note sheet. So there's no items on any kind. Baking soda, this one's usually a little harder. The video we watched actually said differently than this. Does anybody remember where we placed this? 10.5. We placed it on 10. Yes. Around 10 says baking soda. And could you do this if you had a bunch of them and you had spots that you were required to put them in? So RC Cola, we could say any cola. We'd say Coke, we could say Pepsi. We're not going to quiz you on the difference between Pepsi, Coke, and RC Cola. 3. So Cola, it's a little less. It's like 2 point something. I think this one's like 2.3. So what you need to understand is that all colas are going to be around the line that's a little over 2. You do need to know that. That being said, this one you must know. Drano will be at 14. That is a bookend. Suggestion, even put a little star next to it. That is a bookend on this pH scale. You need to know that Drano is the most alkaline or most basic. All right? Now, every year we throw in different sodas. Your job again is to know that cola is the most acidic. What's the least acidic? Any kind of a root beer. So any other soda we give you, Mountain Dew, a Sun Drop, Sierra Mist, 7-Up, whatever it is, will always be in between. So you do need to know the ranges. So Sierra Mist, anybody want to take a stab at that? It'd be 3-ish. So anywhere around that, it's usually a little over 3. But it's around that area, right? So, but we'll get to the other soda in a minute. Anybody remember blood from that video?
It's like 8.
It's between 7 and 8. It's like 7.3-ish. Body's pretty amazing. Keeps our blood at a very constant pH. Anybody who's taken anatomy from Mr. Anderson knows a lot about that. But I couldn't put it the picture was too big to fit it exactly where I wanted to. Anybody remember coffee? Anybody remember coffee? It's okay if we don't, but
6.
close.
5.
It's like 5.5-ish. It's around 5 depending on your brew and the bean. All right, got to know where this one is. Battery acid is at
1.
We're going to say 0. Now, there are exceptions and different kinds of batteries and battery acid, but we're going to say that that's 0. Stomach acid would be 1. That's what we're going to say. So then root beer, now you have this. At this point, you could place root beer at
Or 4.
around 4, right? It's like 4.6, 4.5. Okay, we're not going to say, hey, A and W and Barks, which one? Like, that's ridiculous. And then finally, you got to know this one. Water is going to be at 7. Right? That's our neutral. So acidic, basic, neutral. You have to know those spots. So by the time we're done with this, you've probably done this 4 times. I have no hesitation of giving you a list of anything, and we will give it to you if you look at your worksheet. You don't have to right now, but in the lower right, where there's actual lines, you should be able to do that then. Process of elimination. If we ever give you one like, whoa, you didn't give us that, then place ones that you do know and start placing them properly, okay? So that's pH scale. Moving on. Conjugate acid-base pairs. So again, let's stay on our worksheet or a note sheet here for a second. I have 2 examples for this. What I'd suggest doing, I don't have it like this, I make brackets. Okay, so Ha, the element of surprise, would be linked with what on this one? Its partner is A. So I'd make a little bracket right here. Make it small, don't go crazy. And then the B, this is made up. This is not a real reaction. Okay, is linked to there though. So what I would suggest, just for our notes one more time, and see if you remember this. Above acid and base, what I would do is write what it does with an H. An acid gains or loses an H. A base gains or loses an H. Which one does which? You need to know. And maybe you don't memorize both, but you got to know what they do. They do the opposites, right? So acids lose. So write lose H, or write lose H plus, or something. Like right off of the word acid, and then I'd write gains H, or gains H plus on the word base. Very important. So here's how we do this. And it's very easy to mess this up. I have AP students doing this all the time where they mess this up going back the other way. If I look at this, we bracketed that to A minus. I don't have a bracket, I apologize. But from here to here, it what? It gained or lost? It lost. What students do, and I bet you've done this, where you do this, you go, oh, it gained. And you just tricked yourself because you just went, I mean, it's very easy to do though. Like, oh, it gained. It lost from here to here. So the minute I say it lost, this is an acid. Now, the minute I say that, everything else now falls into place. If you're like, I don't get it. If you have an acid, the other has to be a base. If you have a base, the other has to be an acid. This side are conjugate acids and bases. Their partners are opposites. So if this is an acid, this is a conjugate base. So those are my answers. But notice, the C's have to be on the right. Great question last hour. Can the C's ever be on the left? No. Those are the partners to the acids and the bases. Okay? So the minute I say that, just slow down. Find something you know. Oh, that's an acid. Then there has to be the base. The partner to the acid has to be the conjugate base, so this one automatically has to be the conjugate acid. Slow it down. Why is it this? If I go back this way, what is this thing doing? It's gaining. And what do things gain? Those things are bases, so that's why that is a base. It acts like a base going the other direction. So what I'd like you to do is put a bracket on each of these, and without me saying anything, can you label A, B, C, A, and C, B's, please? And compare with someone next to you, or compare with what I have in a minute. We don't require the brackets. I think they're important, especially on a quiz. I would do it just to ensure that I'm on the right track. My best advice would be, again, slow down and get one thing right. Like make sure, okay, I have to make sure I got this right, and then it all just falls into place. Like everything has to go. And I don't actually process each one of these. I don't go, oh yeah, that gains. Oh yeah, that loses. Oh yeah. I don't need to do that once I found one. So HS, what did it do? It gained. So that is a base. So that's a base. I have to say acid, right? Automatically. If this is a base, its partner has to be the conjugate acid. And if I say the conjugate acid, the other one has to be the conjugate base. Before we move on, because this is going to be important, what happens when I add H's? What happens to the charges? From here to there. It's not there, so it went from negative to 0, so it became more positive, right? If I lose an H, it loses a positive or becomes more negative. So whenever I'm adding an H, I'm adding one positive. So it's literally like simple math. I have a -1, plus 1 is 0. I have 0. If I take away plus 1, I take away a 1, I have a -1. So if this was -2, now this would be -1 because I added 1 to it. So let's see what we're talking about. I think this is the hardest thing today. So I want you to determine the conjugate acid. Let's think about that. If I want the conjugate acid, what's its partner over here?
Base.
The base. So what I'd like you to do is right above it is actually, you may not need to write all that, but I would write something about like these must be bases. Okay? Do that. Like, so this is on the left side. You won't be able to get this right if you don't think about what you're looking at. Every one of those items has to then act like a base. If it's going to act like a base, it's going to make a conjugate acid. And what do bases do? They gain an H, right? So if I have H2O, I'm now going to have an extra H, right? So I have an H3O, and when I add H's, I become more positive. So it should be H3O plus. See what I've done? I have to say first, what is this thing acting like? First off, here's a little hint. On this one, can't give away an H if I don't have one, right? If you're like, oh, it's an acid. I can't even give away, like how does it give away an H if it doesn't have one? So this has to gain an H, right? So if it gains an H, now the formula is HF, any charge? No, because plus 1 and -1 would be 0. So do the last one without me. What would that do? Little hint, by the way, where just like this last one, wherever there are H's, if you're adding them, add to them. Don't like have an H somewhere else. Unless if it looks like it was taken away from somewhere else. So I hope, I'm not giving you a lot of time, but I hope you wrote NH4+. If you forgot the charge, go, it's not a big deal. It's enough to at least get a half point off. Like make sure, if I'm adding H's, I'm getting positive. Okay, flip the script. If I want to see B, it means it had to come from an A, right? So personally, again, I would write on top something about the fact that these are acids, or think acid, or something. So I have to now think of that as an acid. And it's really weird to actually say that water can act like an acid or a base, because our minds only think about, dissolving bases and bones and skin. But yet, the way that an acid is defined, it's actually just about giving or receiving H's, depending on if you're talking about a base or an acid. So, if in this case, to get a conjugate base, it has to act like an acid, so it's going to lose an H, right? So, if it loses, it also becomes negative. Now, the reason why I write OH and not HO is technically water. Technically, we write it as HOH. So it's HOH, and the OH and the H are two separate things. So we remove that first H, technically. If you wrote HO minus, we wouldn't mark it off, but OH minus is better because of the way water actually interacts and behaves. Okay? So what I'd like you to do is do the next two. Just like this, you guys, we didn't worry about if there's 2 or if there's 3. You're either adding 1 or you're removing 1. So do the next two if you haven't already. What would it do? I think this is the trickiest part for students doing this the first time. And I could be wrong. So this one would be HSO4 minus. And the last one would be NO3 minus. That's it. So, if you got that, great. If you're starting to at least see it, I don't think you can get any of those red ones right. If you don't, quickly just take a breath and go, what are those gray ones acting like? Are they acting like a base or an acid? So, you have to take a breath and go, okay, if I want a conjugate acid, they are acting like a base. If I want a conjugate base, they're acting like an acid. All right, so let's get into some calculations. I need you to understand, and I believe this is on your note sheet, is that correct? These are all going to be given to you just like this on your test, on your quiz next week. Just like this. So all it is about application. If you're like, I can't do this, then you're not trying at all. Because we're going to give them to you. Here is the biggest thing for this, is that some of us, if we're struggling, we are having some issues with our calculators, and we do have different calculators. Some of us do have bigger challenges than others because of our calculators. So if you're not getting the answers during the hour today, next mod, let's talk about it and we'll get you there, okay? So either you're hitting log or you're hitting second and log, which is, I don't know if you can see that, but 10 to the x. So to me, I look at what I have and what I'm trying to find, and I use these equations to figure that out. So instead of talking about hypotheticals, let's jump into it. So the first problem, I did this on purpose, says determine the H3O plus. What is H3O plus? H plus. So I don't know if you want to quickly just put an arrow and write that. I did that on purpose. H3O plus is water with an extra H. It's called hydronium ion. We don't have enough time to go into all that. This is a shortcut of writing that. But on the test, you can't be like, hey, what's this thing all about?
Wait, so how do you know that was H plus?
They're this.
It's just.
It's H plus is a shortcut of saying basically it's an extra proton. It's an extra H floating around in water. Think of it that way for now. But they're the same thing. It's just a shortcut. Okay. Determine that of HF that has a pOH of 12.79. Okay. Here's my issue. OH is about bases. H pluses are about acids. So the fact that we have opposites is going to take 2 steps. So this is how I would suggest doing this. What's cool? There's always 2 ways to do this. So what you could say is, okay, I need H plus, I have pOH. I can look on here and figure that out. Well, here's the first thing. I want H plus. The only equation here that uses H plus is this one and this one that's solving for it. So check this out. This one solves using pH. Well, I have pOH. Is there an equation that uses pH and pOH? Right there. So what do I need? I need to go backwards. I need to get what? I need to get pH to plug into here to get to my answer. So this is what I'm going to do. I'm going to take 14 minus my pOH, and I get 1.21. Then I'm going to plug that in to this equation. And I need you to plug this in. I need you to see this on your calculator. Last time, just make sure like, yes, I'm seeing this. If not, this is more about us just figuring out what we're not doing right with negatives or 10 to the x than anything else. Are we seeing that number waiting for us? If not, we'll get that fixed at the ending of this model. But I just take a breath and go, what do I have and how can I get there? Right? I mean, you could have went backwards. Well, pOH, the only one, you guys, on this one, by the way, I don't look at that. I look at this one. pOH is used in this. Oh, it solves for OH minus. You know the other way you could have done this, by the way? You could have put pOH here, gotten OH minus, and then what? I could have plugged it in here, divided it under that, and then gotten H plus. I could have done it that way as well. I don't like that as much, because I have to do 1 EE negative 14. There's more error with that usually, but there's always 2 ways to do it. So if you got that answer, great. If not, we'll get you there. So that's the first problem. Second one. I want the concentration of hydroxide in my stomach, and I have a pH of 1.3. Okay? So I'll give you about 10, 15 seconds. What's your game plan? I know this for a fact. This is pH, that's H. This is OH. It can't be one step. I'll tell you that now. If this was H plus, then it's 1 step. If this is pOH, that'd be 1 step. So do you have a game plan? If you don't, the biggest thing is find an equation that uses, not solves for, uses pH. That's the only one. Or that one, right? It's either way. Well, if you can use this, use it. If you can ever use that equation, life is easier. So that's what I did. But maybe your brain didn't see that. Maybe your brain saw the pH right here and you're going to solve for H plus and then plug in H plus right here, divided under 1 times 10 to the negative 14, which is the dissociation constant of water. We won't get into that.
I got 1.995 times 10 to the negative.
Well, let's find out. So you plugged it in to this equation then, right here, because you found pOH.
Yeah.
1.995 times 10 to the negative 13. What did you get? Times 10 to the
Negative 13.
perfect.
I rounded to 10 minutes after all of them. That's a terrible habit.
I mean, you will not be successful in life by rounding it to 2.00.
Do you have to put M after all of them?
When you are solving for a bracket, yes, that is the unit. A bracket means concentration. Just for concentration. Good question.
Wait a second. Repeat that.
When there's a bracket means concentration. So our unit for concentration is big M.
Understood.
Okay. So we only have one more. And then we do have to do one equation in the back. I did make a mistake. I did not include this, but it's not up there. What? Last one. So I want the pOH of a 0.045 molar solution of HNO3. So, what is M? We just said it. What is M? It means concentration, so it's a bracket. So this is a bracket of something. Guys, it's either of OH minus or H plus. Think about the formula that's given to you. I'm going to just step aside and not say anything here. This is our last calculation for acids and bases. So try to do it once. If you're stuck, we'll go through it. We'll give it a shot. Work with someone else if you need to.
But then calculation, and it was like 10, or it was just, I don't know, 3, 10, minus, like 5.85.
H and
And
O
then
three.
the answer key was like, wait, I think I know
Something
like
like
this.
No, H and O is an acid. It's got H in front of it, bro.
I was just confused now.
Wait, hold on. Take me back.
I don't see it go to here.
Then H
Oh, wait,
minus
wait.
H, don't you?
Wait, this
Just
is
to-
not labeled as this. I got an answer. This is not, but I didn't appeal.
Alright, so they already give you the acid, so obviously it's H plus.
What is the 0.045 molar? It is the bracket with for H plus or OH minus.
H plus.
It's H plus because it's an acid, right? Arrhenius define acids as having an H or a base having OH. So that's how we're going to kind of go for now. So to me, guys, I'd use this equation right here. And then I find pH. You could plug it in here, divide and get OH minus, and then you could put OH and find pOH. But this is what I did. See? Yes?
So like, if it has like an H in front of it, obviously so we had like kind of like let's go get the H.
Mhm.
It was like an acid, but like that's how you can tell
Yep.
that if it's just an H.
Yep. So my pH is 1.35, and then I took the shortest route here, and I just subtracted it. And my pOH must be 12.65 then. So I hope you see there's a lot of similarities with this.
There's no use.
There is no unit on pH. There just isn't. I mean, I guess we could talk about the voltage that is involved, but
Negative log.
how do you, we'll have to go through each calculator is different. Okay, when you're done with that, please flip it over. We have one last little thing. You have done this before. This actually links to our lab on Monday. So please write neutralization on the top. It's not nearly as difficult as it sounds. So, you don't need to write all this. If you want to, you can. I'll leave this up and freeze this for the next 10 minutes or so. But what you need to understand, when you say something's neutralized, what's the thing we put on the top of our pH scale? Wasn't it water? Neutralize is neutral. So when an acid and a base react, is what they do is one of the products is water. And that's an easy way to remember it because it's neutralizing it. So here's just an example. You don't have to write this equation down necessarily, but see how that H and that OH become HOH, which is H2O. This I want you to put in a big box though. So if you just even wrote neutralization and then a big box, that's huge. I hope that looks familiar. Wait, I feel like we did M1V1 equals M2V2. It's the same concept. Exactly the same concept. Just MAVA, A means acid, equals MBVB, which B means base. And it's your choice if you want to write this. And I'm sorry, I'm not trying to rush you. You have time to write this. You can leave spaces for now. Is that if you take molarity, which is moles over liters, and you multiply it by liters, what's left is moles. And for all intents and purposes, if we're still confused or never understood the word mole, mole is just basically the amount of stuff you have. So if I say I have this much stuff of acid, and I make it equal to this much stuff of base, then I'm equal. That means I've neutralized it, and all I have left is water and salt, and then my pH is 7. And that's the whole point. You have to neutralize things sometimes before you discard your chemicals. Really acidic or really basic solutions are not okay. So we need to neutralize that so it doesn't have the ability to corrode or to break down or react with something that we don't want it to. So I have one and only one equation. This could happen in a lot of ways. Maybe you find another chemical and you need to discard it. Maybe it's on a table, there's an acid spill and you want to neutralize it evenly. It says how many milliliters of a 0.95 molar solution of sulfuric acid would be needed to neutralize 45 mils of a 1.68 molar solution of potassium hydroxide. All you have to do, like before, is you link them. Right? You link the volume of the base with the volume, or the molarity of the base. You link the volume of the acid with the molarity of the acid. And it's that simple. So which one don't I know here? Which one don't I know?
Milliliters of.
So my VA. So literally, guys, I mean, that's what I'm plugging in. I hope you see it. Oh, there's my, and I know you're still writing the equation. And again, I will pause this and you can write it down as you go. But there's the molarity concentration of my acid. I don't know the volume of my acid equals the molarity of my base and the volume of my base. Think about this. If you're writing, just take a moment, just pause for 1 second with me. The base is much stronger, correct? So would it make sense, should I have more or less acid to neutralize this if this is much stronger than that?
More.
I need more of this because it's not as strong in a way. Does that make sense? Like I would need more of it because it's not as strong. So my answer better be bigger than 45 because I need more of it to neutralize that.
Makes sense.
So it's 79.6 if you do the math. So that's all that is. So if it ever asks for something to neutralize, which we will be asking you to do that, it's just M1V1 equals M2V2, but we make it more specific, saying MAVA equals MBVB. Bless you. So what I will do, some people last hour wanted that up, so I will leave that on this screen. So I will leave that right there. So just a reminder, by the end of the mod tomorrow, we are stamping the front page of your packet. So that means hero, sidekick, villains, and the city, I believe. I think that's where it ends. You get a stamp. If you don't get a stamp, you lose points eventually when you hand it in. So that would be good to have that done. Obviously, you can be further than that. So what we are for the rest of this mod, we're exactly where we need to be. You can be working on acid basis 1, acid basis 2, or be working on your superhero stuff. If you are further than that, then you can be working on your character board. If you're further than that, you can already start sketching and making mean stick people or whatever you're going to do. Not mean like, well, they could be mean. Awesome. So, let us know what we can do for you.